All right, guys, so before we get started finishing the note sheet from Tuesday, are there any questions over any of the assignments so far?
Why is it so hard?
All right, guys, if there's no questions over any of the previous assignments, let's go on and finish these up here. Now, for us to be able to add or subtract two rational expressions, we need the denominators to be the same. So the first thing we need to do is both denominators, we need to factor them down as far as they will possibly go. The numerators at this point are going to stay the same. So we'll have 8 on top of the first one, x on top of the second one. Now 12x squared is as simplified as it gets. We can't reduce it any further than 12x squared. It doesn't factor any farther than that. There. Now if we look at the other side, x squared plus x squared and x do have a greatest common factor of x. And if we factor an x out of x squared, we're left with x plus x factored out from x factored out completely, leaving us with 1. Now that we have both of these factored completely, we need to get the denominators to be the same. So we're going to be multiplying both of these fractions on top and bottom by something, so the denominators are the exact same. So we can start off with the one on the right. So if we look at x times x plus 1, what does 12x squared have that x times x plus 1 does not have? The 12. So we need to multiply top and bottom by 12. Anything else that the left one has that the right one does not? Because the left one has x squared, the right one just has x. So it's missing an x on top and bottom. So we also need to multiply by x. So the right side needs to be multiplied by 12x over 12x. Let's look at the left. So what does x times x plus 1 have that 12x squared does not? X plus 1 on top and bottom. Because we do have x, but x squared already takes care of that, because x squared is x times x, so that's covered. The only thing it's missing is the x plus 1. And again, we can start off with multiplying the denominators first, just to make sure they are the exact same. So on the right, 12x squared times x plus 1 is just going to be 12x squared times x plus 1. We don't want to distribute that through. We don't want to do 12x squared times x and 12x squared times 1. And the reason for that is because if there is something in common on top and bottom, once we finish adding and subtracting, adding or subtracting, we need it factored. 12x squared times x plus 1 is already factored. If we multiply it through, we're going to have to undo it later. On the other side, 12x times x is 12x squared. We have it multiplied by the x plus 1. So the two denominators are the same. Now the numerators we will need to multiply through. So we'll do x times 8 is 8x. 8 times 1 is plus 8. On the other side, we have 12x times x is 12x squared. Now, since it is addition, we can go on and add them together. There is no issue with sign changes. So what we get is 12x squared plus 8x plus 8 over 12x squared times x plus 1. Questions? Questions, guys? So before we finish this one up here, is there a greatest common factor between our three numerators? Is there a number that will go into 12x squared, 8x, and 8? 4, yes? So we can factor that out. If we factor 4 out of 12x squared, we're left with 3x squared. If we factor 4 out of 8x, we have plus 2. Now the reason we need to factor that out is, well, we do have something in common on top and bottom, the 4 over 12. Because 4 over 12 here will simplify to 1/3. Because both have a common factor of 4, 4 over 12 will reduce to 1/3, leaving us with just 3x squared plus 2x plus 2 on top. In the denominator, we have 3x squared times x plus 1. And that is as simplified as it gets, because the 3x squared plus 2x plus 2 does not factor. That is a simplified form already, and there's nothing else in common on top and bottom. It might be tempting to say that 3x over 3x will cancel, but that 3x squared is stuck together with the 2x and 2. There's no way to actually simplify that down. Any questions over this here? Because here, all three terms have a greatest common factor of 4. And if we divide it out of each term, we get 3x squared, 2x, and 2. Now, the main reason we need to do that is because out front here we have that 4 over 12, 4 being multiplied with the top, 12 with the bottom. Those will reduce. Because if we can reduce it, we need to reduce it. Any other questions on this here? Let's look at the next one. This time we're finding the difference, subtracting. Now, finding the difference isn't going to be any different than what we just did, except instead of adding the 2, we're going to subtract. Now, we do need to be careful with subtraction, because the numerator of what we're subtracting, the signs will change. Signs will change. So we need to be paying attention for that there. But at this first part, x plus 2 and negative 2x minus 1 will stay the same. We need to factor the denominators first. Now, our first denominator is 2x minus 2. Well, between these two terms, there is a greatest common factor of 2 we can factor out. So if I factor a 2 out of 2x minus 2, we're left with x minus 1. Our other denominator, x squared minus 4x plus 3, will factor. Since the 3 is positive, our signs are the same and match the sign of the middle term, which should be negative and negative. Factors of x squared are x and x. And our factors of 3 are 1 and 3. Now we need to multiply both of these by something on top and bottom so we get the denominators to be the same. So the 1 on the left, so x minus 1 times x minus 3, what is it missing that 2 times x minus 1 has? So this here is missing the 2, so we can multiply top and bottom by 2. Now the one on the right does have 1x minus 1, the one on the left has 1x minus 1, so both of these will need only 1, yes? They both have it, we're good there. So now everything on the right is complete. We have everything that the left one has. Now if we look at the left one, 2 times x minus 1, what is it missing that the other one has? X minus 3, so we'll need to multiply top and bottom by x minus 3. Now we have both denominators the same. And both of them will have 2 times x minus 1 times x minus 3. Now the numerators. Now we're going to have to multiply these out. So for the one on the left, we're going to go on and do x times x is x squared. X times 2 is going to be plus 2x. Negative 3 times x is negative 3x. And lastly, negative 3 times 2 is negative 6. Now the other side's a little bit nicer because we're just multiplying 2x and negative 1 by 2, which will give us negative 4x minus 2. Any questions on this here? Now at this point we can combine like terms. There we go. So we'll have x squared minus x minus 6 over 2 times x minus 1 times x minus 3 minus So questions about what? 2 and 3 here. So x times 2 is here. 2x, well, 2x minus 3x. So we combined like terms. Yep. Get us down to negative x. Any other questions? Okay. Now that we have both numerators simplified, denominators are good, we can go on and subtract. So when we subtract, we have x squared minus x minus 6 being subtracted from negative 4x, not squared, negative 4x minus 2. Now I put parentheses around both because for this here with subtraction, the signs of everything after the subtraction are going to change. Because this negative is going to have to be applied to the 4x and to the negative 2. Now the x squared minus x minus 6 stays the same, but if we subtract negative 4x, a negative and a negative make a plus. The negative and negative 2 make a plus 2. So now that we have that done, we can combine like terms. X squared does not have any like terms, so it's going to say x squared. But negative x plus 4x is going to be plus 3x. And negative 6 plus 2 is negative 4. Any questions on how we got to this point here? Will x squared plus 3x minus 4 factor? Well, we can check to make sure. So our b squared minus 4ac, because if we plug this into a calculator where a is the number in front of x squared, which is 1, b is the number in front of x, and c is our constant term. Let me say second square root. See here, it was, that is 3. 3 squared minus 4 times 1 times negative 4. If this gives us a whole number, then it is factorable. Gives us a 5. So that tells us that this numerator is factorable. Since the 4 is negative, our signs are opposite. One's going to be positive, one's negative. Factors of x squared are x and x. Now the factors of 4 are 1 and 4 or 2 and 2. Which one will we probably need? 1 and 4, and the 4 would be, and the 1 is negative. Because once we factor this, what do we have here? An x minus 1 on top and bottom. Those will cancel out, leaving us with x plus 4 over 2 times x minus 3. So sometimes we do need to factor at the end because there is something in common on top and bottom, and if there is, it will reduce out. Questions on this here? Questions on anything we've done so far? Are you ready for the next one? Let's look at this one here. So for this one here, we do need to factor the denominators and go from there. Now out of the two of them, 2x minus 4 is probably going to be the easier one to factor, so we can do it first. Between 2x and 4, they have a greatest common factor of 2. If we take 2 out of 2x, we're left with x minus 2 factored out of 4 is 2. On the other side, we need to factor the x squared minus 3x plus 2. Since the 2 is positive, our signs are the same and they match the sign of the middle term, which is negative. So we have negative and negative. Factors of x squared are x and x. And the factors of 2 are 1 and 2. So when we look at this here, we can start with the one on the right. What is it missing, or one on the left? What is the one on the left missing that the one on the right has? So the one on the left has an x minus 1. The one on the right needs it. So we're going to have to multiply the one on the right by x minus 1 over x minus 1. It has the x minus 2, so we're good there. Then what's the one on the left missing? The 2. Because it already has 1x minus 2, so we're good there. X minus 1 is good. It's only missing the 2. So the denominator is going to be 2 times x minus 1 times x minus 2. The numerator, we're going to multiply both of them by 2. 2 times 5x is 10x. 2 times negative 1 is negative 2. Our other denominator is 2 times x minus 2 times x minus 1. Now we're going to have to distribute this out, so we'll say negative 2x times x is going to be negative 2x squared. Negative 2x times negative 1, the negative and negative make a plus. 2x times 1 is 2x. Then we're going to do negative 1 times x is negative x. And lastly, negative 1 times negative 1 is positive 1. Any questions on this so far? We good? Thank you. Now on the other side, our right side, we do need to combine like terms. So we'll still have negative 2x squared. But 2x minus x is going to be plus x minus 1. Questions on this so far? Questions on anything we've done so far? Now, we can put these into one fraction. We'll have 10x minus 2 minus our negative 2x squared plus x minus 1. And this is all going to be over 2 times x minus 1 times x minus 2. Now that we have this set up, we can remove the parentheses. The 10x minus 2 is the same, but we do need to distribute this negative through the second. Negative 2x squared is going to be plus 2x squared. Our negative distributed to the x is going to be minus x, and our negative distributed to the negative 1 is going to be plus 1 over 2 times x minus 1 times x minus 2. At this point here, we can combine like terms. So we'll have 2x squared, because it's the only term with x squared. 10x minus x is plus 9x. And negative 2 plus 1 is negative 1. And that's as simplified as it gets. Because there's no way that we can use the factors of 2 and the factors of negative 1 to somehow get 9x. Any other questions on this here? Any questions over anything we've done so far? We feel pretty comfortable with these here. So on a whole, I think for the most part y'all would agree, these aren't in themselves, step by step, are not difficult. From one step to the next, they're not bad. But if we take them one step at a time, each step that we're doing is not difficult. It's just nice, simple steps for the most part, and then combining like terms and factoring. But if we try to tackle this all at once, it does make them a little bit harder than they need to be. And yes, there are a lot of steps to these. Any questions on these so far? This is the last one we're going to look at today, is this one here. So this one here has 3 fractions we're going to add. This one's not addition, subtraction. So we're going to do one here where we have addition and subtraction. So a little bit of each. Now the numerators are going to be x minus 2, 2, and 4x. So I put those in already so we do have it spaced out, because we're going to have to multiply each one of these by something so we get the denominators to be the same. Now we do need to factor them. Well, x minus 4 is as factored as we can get it. There's no greatest common factors. The degree is 1. So that's already in simplest terms. The same thing is true with x. It's as simplified as it gets already. Now x squared minus 16 will factor. X squared is a perfect square because that's x times x. 16 is a perfect square. It would be 4 and 4. So we get x minus 4 times x plus 4. Guys, any questions on this so far? Thank you. So if we look at the 3 denominators, so we have x minus 4, x, and then we have x minus 4 and x plus 4. So if we look at the last one, x minus 4 and x plus 4, what is it missing that the other 2 have? Well, the middle one has just x, yes? So the last one is going to need to be multiplied by x over x. Now the first one has an x minus 4. It has one of them, yes? The last one has 1x minus 4, yes? So in all 3, we're going to need how many x minus 4s? Just 1. So the last one already has it, so we don't need to add that. X plus 4 is going to need to be included once, because it shows up in that fraction once. Does x plus 4 show up anywhere else? No, so we only need 1. So the last one is finished. All we need to do is multiply it by x over x. Now the middle one just has x, but it also needs an x minus 4 and, so the middle one is going to be multiplied by x minus 4 and x plus 4 on top and bottom. And lastly, now this first one here has an x minus 4, so that's covered. It also needs an x plus 4 and an x. is all three denominators are going to be x times x plus 4 and x minus 4. Middle one is going to be x times x plus 4 times x minus 4. And the last one's going to be x times x plus 4 times x minus 4. Now the numerators, out of all three, the easiest one to multiply together is the last one here. 4x times x is going to be 4x squared, x times x. Now if we look at the middle one, we'll have 2 times. We're multiplying x minus 4 and x plus 4 together. Where did we get those two factors, x minus 4 and x plus 4? Because what are the factors of x squared minus 16? Isn't that this right here? X minus 4 times x plus 4 did factor from x squared minus 16, yes? So if I'm multiplying these two together, well, we got them from x squared minus 16. So we can replace that back in. Because we could go through the process of doing x times x times 4, negative 4 times x, and negative 4 times 4. The middle terms will cancel out, and we're back to x squared minus 16. If we know two of the factors that were multiplied together came from one already, we already knew what the polynomial was, just replace it. We don't have to multiply back out if we already know what it came from. Now the last one, we're not going to multiply the x in. We're going to do our x plus 4 times x minus 2 first. Now, unfortunately, we don't have a polynomial that both of those factored from, so we're going to actually have to multiply this out. So we'll do x times x first, which is x squared. X times negative 2 is negative 2x. 4 times x is going to be plus 4x. And lastly, 4 times negative 2 is negative 8. All right, so we finished multiplying that out. Now we do need to combine like terms. Yeah. We'll go on and do kind of 2 steps in one so we can start condensing this down. Because what we could do is rewrite combine like terms. Then we're going to need to multiply x. So here we can say x times, this is going to be x squared, plus 2x minus 8, plus, we can go on and distribute the 2. 2 times x squared is 2x squared. 2 times negative 16 is going to be negative 32, minus 4x squared. Okay. That's fine. Now at this point here, we're going to distribute the x through and our signs as well. So x times x squared is going to be x cubed plus 2x squared minus 8x. We just multiplied each of those terms by x. Now our 2x minus 32, since the sign in front of it is plus, we're going to have 2x squared minus 32. And we distribute the negative to 4x squared, we have negative 4x squared. Any questions on this here? Because we have one last step after this and we're done. Combine like terms. Now x cubed is the only term with a third power, so x cubed is by itself. So we have 2x squared plus 2x squared is 4x squared minus 4x squared is 0. So it is gone. There is no x squared terms because they all canceled out. And our only x term is negative 8. So we have negative 8x minus 32. Now, for us to be able to really factor the numerator, we're going to need 4 terms because we would need that x squared to kind of do grouping and go from there. Since we have 3 terms, that is, as simplified as it gets, that is our final answer. Now, again, the difference between Algebra 2 and college algebra is very little. There's a few things that are going to take a step further than what we do in here. This here would be considered college algebra. Because instead of adding or subtracting 2, we're adding subtracting 3 or more. That's the only real difference. But that is all we're doing in here today. This is your assignment. There are 12 problems on it. 4 through 6, 8, 12 through 14, 20 through 23, and 26.